All right, guys, this is lesson 2, the second part of 8-4 to name triangles. I'm going to jump right in because there's a lot I want to try to get to today. So I want to remind you what we talked briefly about yesterday. We talked about an equilateral triangle being a way to name a triangle based on its sides. We also had an isosceles and a scalene. And again, I don't totally know where these names come from, but they're just important ones to remember. But what's going to be really cool and helpful today is I want you to notice these lines. So these lines are actually telling you that there is an equal-sided line somewhere else in your triangle. So for example, in this little equilateral triangle, the fact that there are 3 lines tells you that all 3 sides are the same. But in this isosceles triangle, when there are only 2 lines like this, that's telling you that only these 2 lines are the same and that this one has a different length. So for example, real quick, if this was 3 centimeters, this one would obviously be 3 centimeters, and this guy right here is going to be anything but 3 centimeters. Let's say for today it's 1, okay? So that's going to be another way that you could name this triangle. So this triangle would be called an isosceles triangle. This one could be called an equilateral triangle. And like I briefly yelled at you right at the end of that video, this last one called a scalene isn't going to have any of these little lines because there are no lines that measure the same. So for example, this one could maybe be 2 centimeters, and maybe this one is 5 centimeters, and maybe this one down here is 7 centimeters. So it still has a name. It's called a scalene triangle, but that's only because it doesn't have any equal sides. So if we were to look at down here where it says use these triangle to answer the questions, these are the triangles we're talking about. So let me come over here. So it wants you to write the letter names of the scalene triangles. You have to remember scalene is the one that's trying to tell you that there are no sides that are the same. This one right here has no lines that are the same. So we're going to name that triangle, doesn't matter what order you do. Let's say STU, okay? And then another one, I'm going to check that one off for now. This one has little lines, this one has little lines, this one has little lines, and this one has little lines. So this last one right here is probably our other triangle that is a scalene, and we'll label that one DEF, D, E, and F, okay? So now it wants us to find equilateral triangles. I'll put a check mark next to that one. Equilateral triangles are your one where all 3 sides are equal. Okay, so for example, right here for A, I can see that these 3 are all the same. So I would label this as triangle A, B, and C. I'll put a little check mark next to that one. And then if I come down here, this one only has 2 sides that are the same. This third one is not, so that's out. And then that's the same thing going on here. These 2 sides are the same, but that one's not. But here I have my 3 little symbols. So this is going to be triangle PQR. And then that leaves us only 2, but it makes sense. Again, this is isosceles, and isosceles is where you've got your 2 sides that are the same. And that would be this triangle, excuse me, G, H, and I. And then you've got this other triangle right here, which is triangle J, K, and L. Now, just for the record, I just want to make sure you guys are clear about something like this. I could have labeled this triangle ABC, or BCA, or BAC. It wouldn't matter what order I do, because they all 3 connect together. Just a little sidebar on that one. So let's look at some identifiers on these ones because I want to make sure you're understanding, and I also want to help you remember that these ones are really going to help you out today with these little side symbols. It won't always be that easy, but for today, we're going to start you off easy. So for number 20, we see none of those whatsoever, and so we are going to call this one simply a scalene triangle. And I'll remember we can write that little triangle symbol. And the way we know is there are 0 equal sides. That's how we can write that today. Okay, so for number 21, I think we might be in the same boat. I don't think number 21 has any equal sides. And so because of that, we will call this one again a scalene triangle. We'll just put scalene, and we're going to put 0 equal sides. How about that? Okay, for number 22, do you see here how you've got your 2 little hash marks or your 2 little side marks? That tells me that this is isosceles, and it's got 2 equal sides. We'll write it just like that. And then down here for number 23, once again, we've got 2 of those little equal side symbols. So we're going to call this one isosceles. And it's got 2 equal sides. Hopefully this is going to go pretty fast for you guys. Again, this has 2 equal sides, so we call that isosceles. And again, those are 2 equal sides. And then finally on this last one, this is our equilateral triangle because all 3 sides are the same. Normally when you write the word equal, it's E-Q-U-A-L, but equilateral likes to make life difficult for you, and it's actually E-Q-U-I-L, and then lateral. Try to spell that right, just because it'll be good practice. And this one has 3 equal sides. Okay? So I'm going to go ahead and move on. Again, this is something you can go do on your own as practice today. So I would maybe leave those off to the side for now. But those are 7 different problems that you could do on your own as a little bit of practice. But I actually want to shoot you down over here to this page right here. Okay, so this is going to be a little confusing, but it is going to be really good practice for you guys. And it basically wants to help you see that when we have a triangle, so for example, these are all 7 different little triangles, all by themselves. But what's neat about them is that they have 2 different names. They are going to have one name that is based on their angles. And they are then going to have another name that can be based on their sides. So they have 2 names, but those 2 names are basically kind of working together a little bit to show you, I guess, kind of like how they can just have 2 different names to go with them. So let's look to see what this big whole triangle or circle oval business is here. So this tells us, it says, write a capital letter and a lowercase letter inside each triangle below using the keys at the right. I'll help you with that in just a minute. And then it says, cut out the triangles and use the diagram below to sort them in different ways. Well, I think that that's too hard to do all by yourself, so we're going to do part of this together. We already know that this is totally labeled as triangles. And so what I want you to do is here is we are going to call this side acute. And we are going to call this side isosceles. And that's just going to be one way we can label this. There are lots and lots and lots of different ways we could label these, but you'll see what I'm talking about there in just a second, okay? So if I were to take I'm just going to choose a random triangle to start. So my job is to ask myself if I think that this is isosceles, or if I think it is acute. And if so, if it's both of those, it would go in the center. If it's only acute, it would go over here. If it's only isosceles, it would go over here. And if it's neither of those, it would go down here in the bottom to show us that it's neither. So in order to test if something is acute, we have to see if it has 3 different acute angles. Well, I can already tell that this one, even though they didn't draw it, this right here has a little 90-degree angle symbol. So because of that, I know that this is not acute, okay? Now, another thing that I want to notice is that I want to see if both of these lines are the same distance, I guess I should say. I want to see if they are like the same, how long these both are. And if I were to measure them, these both seem to be the same length. And because of that, I'm going to go ahead and label, I know that that's for sure. Sorry, I don't want that there. I know for sure that this shape right here is an isosceles triangle because these 2 sides right here are the same size. I know they don't have their little lines, but I want you just to trust me on that guy. So what it asked us to do also is to label these, and that means that I need to label this. This is an isosceles triangle, so it's got an I. And it is also a right angle. So I would label that with an R. So this is an isosceles triangle because it has 2 sides of the same length. And it is a right angle because it's got that little right angle right there. Now, let's look at a triangle like this one. So first I'm going to start with its angle. It's got a 90-degree angle right here. So I'm going to label this one with an R for right angle because that's what it told me to do, a lowercase r. But now I need to figure out its side's name. So it's either going to be isosceles, meaning two sides are the same length. It's going to be scalene, because none of them are the same length. Or it's going to be equilateral, because all three are the same length. Well, I can tell you guys now, this side is not the same length as this one. So this is actually going to be a scalene triangle. So because of that, can I put that in isosceles? No, it's not an isosceles. Is it acute? No, it's not acute. So I'm going to have to move it down here. Let's see if I can move. Oh gosh, I have to move them all. You guys get the picture. Okay, so then I can put that right down there. It doesn't fit in either of those spots. Does this kind of make sense how I'm doing this? Let's do another one, because then I might have to have you finish this on your own. If I were to look at this triangle right here, if I were to measure all three sides, it looks to be pretty clear that this one is exactly an equilateral triangle. So I'm going to label that with a capital E for equilateral, and I'll do that in a minute once I move it. But it's not acute. So I can't, oh sorry, it's my bad. It's not isosceles, so I'm not going to be able to put it in here. So my job is to try and put it where it belongs, and that means that I'm going to have to figure out its other name, which is its angle name. So if I were to measure all three of these angles, if I were to use my little right angle tester, I would very clearly see that all three of those sides are acute. So because this is an acute triangle, it can land right over here, and I'm going to now label it with an A for acute, and then also I'm going to label it with a big E because it is equilateral. Okay, so why don't we do this for the interest of time, and because I want to make sure you get this kind of practice, let's just look at these triangles real quick and see what we would label them as. So I'm just going to look at these triangles. We'll just drag them over here a little bit. And I appreciate you guys being patient with me. So what I want to do is I want to see, actually, I'm going to change my mind. Sorry, guys. Go ahead and skip this page. I want you to actually come down here because this is going to be good practice. We're going to draw a triangle as best as we can, and this is going to help us understand some of those words a little bit. So, sorry, I'm bouncing all over the place a little bit. This one wants you to draw a right scalene triangle. So here's what I know about a right triangle. It has to have that perfect little 90-degree angle. And what I know about a scalene triangle is that none of my sides can be the same length. So I can draw this one, and an example of how to draw this one is to make it like, so that line is about that long, this one is super long, and then because I'm having to meet it all the way over here, it's going to end up being longer than that one because it's got a little bit more of an angle to it. And I can now label it with my little 90-degree angle, and I can now tell that that is a right scalene triangle. Okay, next it wants an obtuse scalene triangle. So again, scalene means none of the sides are the same, and obtuse means that the angle is obtuse or more than 90 degrees. So whenever I draw an obtuse angle, I always just go kind of like that, because that clearly makes my obtuse angle. And now when I draw this line, that's also not going to be the same length. So that's going to be a really poor drawing of an obtuse scalene triangle. Now, I want to show you, in the interest of time, here where it says, sorry guys, it says a right equilateral triangle. That's not something that you can draw. If I were to draw a right angle, I can't then connect this in any way where all three of my sides would be the same. So that one doesn't work. And I also can't do an obtuse equilateral triangle. That is not a triangle that I can draw. But I'm going to draw you two very fast examples. This one wants you to draw an acute isosceles triangle. Well, let's say that those two lines are the same length, and then I connect them down here. These two sides are the same, and each one of these angles is acute. And then it says in a right isosceles triangle, I can draw these two lines exactly the same, and then connect these, and that's going to make a right isosceles triangle. So it's just practice, and no, this might not work perfectly. I just want to give you the answers to these ones in case you want to come back and look at it later. That's an equilateral triangle. This is an obtuse angle, and this one has two acute angles. But like I said, that's just so if you want to check them out later. what I would really recommend today is maybe go back and finish up these SAB pages that I asked you to go do, or now would be a great time to try out some of those IXL options. But otherwise, good work today. I know these are kind of hard because it's a lot of vocab to learn.